Well, let's start our webinar. How does that sound? Ready to go?
Perfect.
Okay,
Let's go.
good. Yeah. We got some people who are patiently waiting and a bunch of kids in class watching this on a big display. So let's talk about the Cyberbot, Python, and Microbit. I want to welcome you all to the webinar, most importantly. We have many signups from around the world for this, about 160. So we're streaming this live to Facebook, and we will send out a link afterwards to anybody that's not here. Of course, you're not here. No, you're not here, but we will provide a video link. So before we get started, I want to thank the Parallax team and especially the NYSERC team for all of their work around this project, I'll call it, because it's so much more than a product. We have them in our office today, as a matter of fact. So I'll introduce myself. My name is Ken Gracie. I've been working with microcontrollers and robotics, and especially in education since 1997. I work in Rockland, California. I also have had underway for many years a CTE credential, still going with that. And my co-host here is Kevin Knowlton.
Good afternoon, everyone. My name is Kevin Knowlton. I'm the Director of Academic Outreach for NYSERC, which is the National Integrated Cyber Education Research Center. And I am I call a recovering educator, former assistant principal before joining this great organization, NYSERC. And I just want to say how proud we are as an organization to partner with Parallax to roll out the Cyberbot and all of the accompaniment, all of the curriculum and all the resources that are available to K-12 educators, and many of which are available at no cost. And so being able to partner with great organizations like Parallax and my friend Ken and to really focus on solving a systemic problem that our country faces. We have a challenge that we have to fill the cyber literate workforce of tomorrow, and where best to start solving that problem with K-12 education, with two-year institutions as well as four-year institutions. So NYSERC was an organization that has a grant from the federal government, the U.S. Department of Homeland Security, to bring cybersecurity into the K-12 classroom. And there's a number of ways, and I'll get into that later on down into the meat of the webinar, but there are many ways that we do that, all the way down from starting at elementary, all the way going through high school. So this webinar, we're going to really focus on the Cyberbot and all of its functionalities and how it can scale and how it can scaffold many academic levels and create as complex or as basic as you need for your classroom. So Ken, I'll kick it back over to you, and
Great.
Let's get the fun started.
Hey, speaking of fun, would you mind giving away 2 of these at the end of the webinar? I don't want to be responsible for choosing it.
I think I can, my arm can be twisted for that. Okay. So let's do it.
All right. And also, we're joined by Stephanie Lindsay, who is operating the chat and the Q&A for us right now. So she will draw our attention to anything that you bring up to us. About Parallax, I think most of you know us from the survey. We've been around since actually the late 80s. But making our own microcontrollers and tools since the early 90s. We're located in Rockland, and we have about staff of 20. And Kevin, your organization?
Yeah, so we're an organization that's, again, like I mentioned, grant funded, that develops content and curriculum for a cyber-ready workforce. Our end state and our end goal is to ensure that we have a talent pipeline going straight into the workforce. And what we do is we produce content and curriculum based on the Cyberbot that's available at no cost. And we have a team of north of 20 curriculum developers, master teachers, doctoral degree individuals who have a pedagogical design background, curriculum design background. And we have 5 of our subject matter experts in curriculum development folks in Rockland, California this week, and developing some really cool resources, really cool modules that we'll touch on here in a little bit. But this organization has been around for almost 12 years now and impacted to date over 3 million students.
That's what I wanted to ask you. Thanks. This webinar is interactive too, so feel free to flow your comments, your questions right into the chat as we go. And if you want to use audio, that's even better. We'd love to hear from you. So this is our robot roundtable. Now, how do you do that? Using Zoom. If you're new to this tool, it can be kind of tricky. In fact, the screenshots I have are probably outdated because the tool changes all the time. But you basically have a Q&A chat where you can type, and then you can also raise your hand and unmute yourself to talk. I think actually the sequence is you raise your hand, we unmute you. So yeah, jump on in. So what we're talking about today, we have just over an hour, and we're going to move really quick. And I know for the classrooms out there that are watching this, they just want to get to the robots. We want to see something move. So we're going to get you there as soon as we can. So we'll spend 5-10 minutes talking about the microbit and the Python language for it, and then what educational resources are available for it. And then we're going to talk about the microbit on the Cyberbot and how that works on this robot and what you can do with it and all the resources that are available. So this webinar is mostly for teachers, but I know we have hobbyists, we have product developers, engineers, all kinds of people here. So much of the content you see will be specifically for teachers so they can use this in class. And then we have demonstrations, which are really cool. And we'll talk about support. So your goals that I hope you have in mind are just to enjoy the event, learn about what we offer, to see the challenges. So using every tool like this has a few challenges along the way. I'm going to point them out to you, and you will have seen them. So any hurdle, I think you will have already encountered and you can get beyond just by being part of this webinar. And to give you enough confidence to use them and then to see robots go. Parallax Builds in the USA, I think you know that. The Cyberbot has actually been out for just over a year now. So we have several thousand of these in use in schools around the country, and we're starting to see a lot more Twitter posts and social media evidence of that, and it's going quite well so far. Well, I always like to start out with a slide with this student, and this is Zach, and this is a young man who showed up at our booth at the USA Science and Engineering Festival in Washington, D.C., and he wouldn't leave. So he spent 2 days building everything we can put in front of him, every circuit, and then he'd put them together and take them apart and ask for more, and he made everything work. And what he said, he made a YouTube video, and what he really liked about Cyberbot is he said, there's no black box. This is the real thing. I get to work with components, and the programming is fun. And students often ask me, like, how do you choose careers? My kids are at that age. And I always tell them, I think a lot of it has to do with just what you've been exposed to. You have to find an interest. And so I think the most important aspect of using this in school is just to give students an exposure. There is, of course, a tech education reasoning, but to give them the experience, which they would not ordinarily get, to discover something fun. Sometimes it's just about using your hands. The microbit.
Ken, if you don't mind,
please.
I was going to say, just jump in, just add a little anecdote about that. We run across students all the time when we're in the classrooms. And one of the things I love to do is ask students, what do you want to be when you grow up? And I get all of the different standard answers. I want to be a doctor, a lawyer, a veterinarian. And at one time, a student raised his hand and asked and told me, he says, Mr. Knowlton, how can you expect me to tell you what I want to be when I grow up when I don't know what all the options are? And seeing students like Zach explore the unknown in their eyes, explore the different functionalities to be able to take a Cyberbot and not only get some great skills, but to also gain an awareness of what types of jobs there are that use this type of platform. So Zach, I wish every student was like Zach, but Zach is an inspiration to many in that we're able to introduce students to careers that are high paying as well as in high demand.
There's a really good video. I interviewed Zach on YouTube and posted it. So you can go find that. It's quite well known.
Yeah.
Let's talk about Python and the microbit next. Get a little more specific. So if you're familiar with Python, it's taking off right now. It's being learned more than French, and 3/4 of students asked about their favorite language seem to like this one. So it has the fastest rate of GitHub pull requests right now. And what's really nice is the AP Computer Science Principles does not specify a specific language, and you can now use Python in addition to Java or whatever else you want. So Python's really growing like mad. It started with this person, Guido van Rossum, who's a Dutchman. And just before his Christmas break from his job in 1989, he decided to set off and make an interpreted language so he could keep busy, a fun open source language that reads like English and was easy to expand. And that's exactly what he did over his Christmas holiday 30 years ago. In terms of data, this is the TOB programming index, and it shows all the languages based on popularity, so movements across GitHub. And Python is this light green line here. We thought it would be #1 in 2020, but not yet. So on top of it is Java and C. If I had to summarize Python, I'd say this is what's really great about it. And my background is pretty limited. I'm not much of a programmer, but I have a lot of good experience in BASIC and just a tad in C, a ton in Blockly and visual programming languages. And I think Python looks like BASIC. It's beginner friendly, but it's object oriented. And this is where the power comes in. You can include modules and libraries. What's really wonderful now is it runs on embedded physical hardware through MicroPython. And there's a lot of examples available. There's good tool support, and it's just easy to read. So I think it's a good starting language. Microbit. Okay, let's talk about the microbit, then we'll discuss Python in the microbit. I don't know if you're all familiar with this module or not, but it's been out for, I think, 3 or 4 years now. It has a lot of fun stuff on it, an LED matrix. It has an accelerometer, compass, a Bluetooth radio, which is quite powerful. And you can attach to the edge connector on this with crocodile clips or whatever. So there's quite a bit here just to play with without connecting it to anything. And by far, probably the most popular programming environment for it is the Microsoft MakeCode, but we're seeing the Python, again, just become as popular. So you can get one of these, plug it in, and go online and start doing stuff right away. And you'll see a lot of applications like this as you browse the web. So it's popular for art applications, elementary school. It does well with sound. These are actually modified milk containers, and they're using the microbit for expressions with the LEDs and then just turning parts of their eyeballs or something with servos. So a lot of fun stuff like that out there. MicroPython came from this gentleman. This is Damien George, and he's an Australian. Oh, I think 4 years ago, he started a Kickstarter project that was very well funded to write an interpreter for microcontrollers. And it would be a reduced version of Python that has pretty much the simpler things you need in microcontrollers for program structuring, etc., but the power of Python, but also with some ability to control hardware, like all the I/O pins. So he did this, and several variants were produced of the interpreter right away for different microcontrollers. Like there's one for the ESP chips, microbit. I think there's some more powerful ones for BeagleBoard. The Propeller 2 actually has one. So let's hook it up and just see some code run. Basically, just grab the microbit and you connect it to your computer. And then here's one of the first really cool things I like about it. The editor is online. So you just go here to python.microbit.org, and then you go to connect, and it will find the device. And this little program just makes a beating heart, so we will download it. And here it is. So I'll make a quick change to, it's kind of bright in my office. I don't know, can you see that, Kevin?
Yeah, I can see it loud and clear.
Yeah. All right, so yeah, and if you want a much faster heartbeat, here you go. Okay, boom, 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 boom. get the defib machine. All right. So you got the idea. So you could write code right here in this editor. There was no software installation. So for teachers, this means COPA compliance does not apply, and you can just plug it in and go, provided you got a browser. So there are a whole bunch of examples out there. This is one I just showed you. And here's some scrolling text. So people use the LED display on it for showing data. It also shows errors that occur. These are some of the first things you would do with it. It has a couple buttons on it. And it checks the status of the buttons, stores them while you're in the background, which is kind of nice. And it's pretty much a fully featured Python language, and it has all the pieces we would expect: modules, methods, functions, and you know, lots of libraries you could bring in. There's a list of them on the microbit website. There are libraries for radio, speech, accelerometer, neopixels, random data, and so on. So you just go there.
And Ken,
yep.
Yeah, just really quick add on about that LED display. One of the things that if you're using some of NYSERC's content curriculum, many of you are familiar with the Pigpen cipher activity, and you're able to decrypt messages that students will have to, or rather, you're able to encrypt messages and display the Pigpen cipher right on the LED screen, and then hand it to another student or hand it to a colleague or hand it to a friend, and they have to then decrypt that message. And this is really at a foundational level where we're able to start integrating cybersecurity into the functionality of a microbit. And you can start that as early as elementary school with the Pigpen cipher activities.
Yeah, and the radio lends itself very well to that too.
Mm-hmm.
This is an alternative editor. If you do want to install software, you could use the Mu editor. So this is for Windows Mac. Just downloaded it, and we will run this code and then open up the plotter. So this is actually a display of the 3-axis accelerometer. So as I go up and down, it must be that Z is the orange line, and then tilting left and right, showing you X and Y, and then shaking things like mad. So the benefits of Mu are that it has some nice syntax checking in it. It's a little bit easier. It has a plotter. You know, it has different themes you can apply like this. So we just have started using this tool a little bit more. In the beginning, it had some trouble with tabs versus spaces, but that seems to be worked out now. So this is your alternative editor if you prefer. We pretty much support the online Python, but they both work very well. So about the educational resources for the microbit. And again, I show this because there's a lot you could do after you get this controller. So, you know, here's a box of 10, they're 170 bucks, thereabouts, or you can buy them individually for 17 bucks. And you can be programming in Python for days before you actually hit the robot. So Kevin, what is this? This is from your...
Yeah, so this is a snapshot of the NYSERC website where you're able to download these different types of activities. And so what you see on the screen here are the different lessons, and these are just, you know, 6 lessons, and I think there's about 12, 13 different lessons and activities, but they touch on each one of the different functionalities of the microbit, and this is in our Cyber Fundamentals course. So the Hello World, the very foundational test of the device and scrolling text. And then we're talking about displays and introducing variables and animations. And then we begin talking about the different functionalities of the buttons and the conditionals and so forth. So we start at a very baseline and then get very advanced with the microbit. And these lessons are able to be done in Python or in block-based. So depending on the level in which your students or your hobbyists are at, they can then take that microbit and go to any level of difficulty, any level of challenge that they need. So Cyber Fundamentals is just one of many courses that NYSERC offers. And Ken, if you want to click one over to the next slide.
Can I break
I'll
in
touch
with it?
on, oh yeah, certainly.
I just wanted to point out that David Smith is asking in the chat, that he's a developer of the VAHL system and is asking if this would be a better platform than the Bobot or the Spin language, since you were discussing the flexibility of language options. I thought that was a relevant question.
Yeah, so I'll just take the first stab, and Ken, you can follow it up. But you know, what I like about the versatility of the microbit specifically is that I can take the microbit and the fundamentals that are around the microbit, and I can quickly go up into the Cyberbot. I'm able to take the same programming, but introduce at a more advanced level the different ping sensors, the ultrasonic sensors, the touch sensors. So I'm able to scaffold my content and my curriculum so much easier. The Bobot is great. Don't get me wrong. We still provide schools with so many Bobots every year. But if you're looking for a means for educating both freshmen in high school as well as seniors in high school all in the same classroom, then the Cyberbot is really a good vehicle for that.
Yeah, I'd agree with everything you said. And how about this? This is your cyber information interstate.
So yeah, so this is our cyber interstates from a content perspective, and this shows all the elementary all the way up through the high school content. But some of the things that I want to draw your attention to are the cyber fundamentals, the cyber literacy 2, cyber science, the cybersecurity fundamentals. All of these courses utilize either the microbit or the Cyberbot or both. And you're able to use cyber fundamentals down in the elementary middle. You're able to get into the cyber literacies from the high school standpoint. So there's a plethora of offerings built around this device that supports teachers and introduces students to the skills around programming, Python, block-based programming.
And I should point out, a few of your lessons are available for download on our website, so people can see what they look like. They're on the microbit pages. So what I'm showing too are other resources. Yeah, so Kevin, you have really, aside from the BBC docs, the most complete Python examples I'm aware of. These are good too. So these are just, some of these are Python, some are block-based, but they're from the microbit site. So we could use those. And then here's really the reference guide. And between the reference guide, the NYSERC resources, and the Parallax resources I'm going to show, you have a whole complete class offering to pull from. And there are some videos too out there. Hackster has some neat videos specifically for teachers. Again, just using the microbit with no robot, there's a ton you can do. So let's talk about robotics. Who wants to see this on a robot? All right. Okay, so
Me.
That's it. I can hear everyone else screaming too. Why do we use physical devices for programming? It's for the simple reason that it's more fun, first off, and students can see their code run. So the research shows it's effective, they enjoy it more. You can do classroom competition, and it's just a great way to integrate all the pieces you see here, coding, electronics, building a circuit, mechanical things into one system. And most importantly, we want students to learn about how things work versus just being users. Now, there are a few steps to set this up, and this is common really with all microcontrollers. I'm showing you how it works with the microbit. So to use a Cyberbot, you need to add the Cyberbot module using the Python editor. And you're walked through this with our tutorials, but it works like this. You go to the Cyberbot tutorial, you click on Add Modules, and then you'll find the Cyberbot library archive. And it takes you to our website, and then you can download it. And my internet connection was very slow here, so it took just a few seconds. And then after you download it, you have to open the folder where it is and unzip it. And this will unzip all the Cyberbot code examples plus the library, the Cyberbot library, and the libraries that are inside of the Cyberbot library. So you saw I unzipped it. And then you go back to the Python editor and you go into load, and you will add the Cyberbot library to the microbit. Okay, just like that. And then you can check that it's there by clicking on Show Files, and you'll see there it is, the microbit program and the Cyberbot. So that's it. And that takes, a few minutes to do, but it's necessary. And then how do you do it with Mu? It's kind of the same thing. And I show this just because another editor, another tool, same process pretty much. So what you have to do here is you have to move the Cyberbot library to the Mu code folder. And that's where the Mu editor will look for the library. So you go into Mu, click on Files, and if you put your library inside of the Mu code folder, it will appear. Then you drag it over to the microbit, and it copies. And you could also check it to make sure it's there. So that's it. Now let's talk about making the robot go. Okay, so Cyberbot has on it 2 motors. And to make the robot move forward, one motor will turn clockwise, one will turn counterclockwise, okay? And it has to do with the direction you're looking at the motors. So the robot has many ways it can move about, not just forward, back, left, and right. It could do arc turns and, really interesting organic shapes. The code would look like this, okay? And so you'll notice something new here. We're using the Cyberbot library, and through the bot command, we can specify an IO pin and then a command and then a value. And this is where things really quick become wide open. So to make the robot go forward, we're just going to tell the 2 motors on 18 and 19 their speeds, and then for how long, and then we'll stop it. So for example, I could just take this code and I will copy it into the Python editor. And I will hook up a robot, and then I'll switch my camera over. Thanks for your patience with all this. And move the camera over to the webcam. Okay, so you should be able to see now the webcam, which has a robot, on a tether. I'll move this one out of the way. It's connected to a USB cable. And we're just going to program to go forward for 2 seconds and then stop. So first we have to connect to the robot in the Python editor and then flash the code. And, I have an error, and that error is...
A great learning opportunity.
It sure is. Oh, look at the error. So the Cyberbot library is missing from the microbit. So we'll go get it, and we will just drop it in here. So it's not much of a surprise. There are like 1,000 of these robots around the office. And now that library is there, so we'll try to download again. And then success, drive right out of the screen. Okay, so let's just go get a little better program here.
Can we pause for just a moment?
Sure.
We have a couple questions
Let's
coming
take
in.
'em.
I think people might be trying to take notes here as quickly as they can. Will you be sharing? I know we'll be sharing this video will be posted because the webinar is being recorded. Is this particular slideshow going to be available? There's a request for the slides and
Sure.
also for links for the tutorials.
Yeah, we will distribute the whole thing with the notes that have the links to tutorials after the webinar, yep.
Great. So
And
we'll just make that available to everybody.
Yeah, you'll receive an email afterwards. And you might want to answer to the question about the Eddy platform. 2 very different systems here.
Oh, I haven't gotten to that one. I was seeing another question up here from Donna on how many coding languages can be used with the Cyberbot.
1 at the moment, and that is MicroPython, Python. And there is interest in block language too, but we're not quite there yet. Any other questions like that?
Let's see. Just more requests for the slides. So we'll just assure everyone who's was enrolled in the webinar will get an email with all the links.
Okay, perfect. All right, so are you able to see the programming screen again, Kevin and Stephanie?
Yes.
Okay, so yeah, here's just a little more advanced example with the same robot. And I'm just using functions with arguments. So here's a little more Python for you. So this will just start each of these. And you can imagine what this will do. It'll just go straight, right, straight, right. So if I want to do something like make a square, we'll just make a loop like this. We're going to do the same thing 4 times. And we will go straight, and then we'll go right. And then eventually we will just stop. And what might be fun is let's just pass the value here over the duration. So we'll go straight for 750 and this is in milliseconds, then we'll turn right for 800 milliseconds. And from my tests earlier today, I think that is about equal to, a few inches of travel and then a right turn, a 90-degree right turn. So let's see here. We'll just do some substitution. And this should work, right? Nothing like coding on the fly with a lot of watching eyes. All right. Oh, stop. I don't think we need a duration there, do we? Okay, so let's just download that and hopefully everything goes well. We'll reconnect to the robot. I think we better disconnect. Okay. So reset. Right off the table. Okay, so you got the
All
idea.
right.
So maybe a little, in fact, it's throwing a syntax error because I didn't pass the duration parameter to the stop function. Okay, but you got the idea. So we could work with that and then make it work quite nicely, do a perfect square. Just wanted you to have the idea of that, how that works. So that would be forward, stopping, backward. You just reverse the numbers, right turns. And often people don't know, but a robot can turn right by turning in place like a 0-turn radius lawnmower, or by locking one wheel, then turning the other. You could back up the same way. So lots of ways to go about things. This is similar to the program we just ran. And here's one, functions without arguments. Okay, so what's in the Cyberbot library? So you saw bot pin and then servo speed. There's all kinds of stuff here that you can work with. And we created this because the microbit is good at a lot of things, but there are some things that just can't do. So there is a processor on the board that I'll show you that handles a lot of this for it. But basically you can read the IO pin states. QTI reads line following sensors. You can generate pulses, make sounds. And some of these have a lot packed into them, like IR detect and TV remote. And here's a one-line command for using the ping sensor where it just gives you the distance. So this is the whole library, and most of these are used already in our examples. From a hardware perspective, you will see between the microbit and the breadboard is a Propeller 1 multi-core chip. And when you write commands in Python, the editor sends those commands through an I2C interface to the Propeller chip, which actually runs them on makes the signals available on the breadboard. So this is really transparent. This part is transparent to the programmer, but it's going on. And some of the IO pins from the microbit are brought to the A to D directly too.
I have a question has come in asking, is the only way to download the code by cable connection? Presently, yes, the microbit needs the USB cable connection to be reflashed.
Yeah, good. And this is what the board looks like. So I'm going to switch the camera view over to something a little more handy. Okay, so I think you can look at the slide or the board, but basically the board has on it a mounting bay for the microbit. So you just drop it in there and there's some spring clips that attach to the plates on the microbit when you tighten down the 2 screws. There's a power jack for battery pack. There's a place to plug in a piezo speaker. And then there are I/O ports where you can plug in the motors. And there's something new here, which is a low battery indicator light, flashes red when the batteries go low, and some LEDs to play with. And all of your I/O pins are here. So you have something common to all Parallax boards is a focus on electronics and the use of components. And you'll see our circuits are used in the Arduino ShieldBot, the BoBot, and the same ones are here on the CyberBot. And there's your 3-position switch as well. So what's available for the CyberBot? Okay, we'll just jump over here to learn for a moment. If you go to learn.parallax.com and then you click on the CyberBot, you'll be brought to this page. So think of this as a book, and each of these are chapters. We've divided it into 3 pieces for use in school. There are prerequisites, and then the main lessons and the projects. So the first part is about programming the microbit, and then we get into building the robot and doing all the different projects. So as you click on these, like this one's about using whiskers, and I'll let you do this too on your own because there's 40 hours of work here for students. Usually it starts with a video showing you what to expect when you run it. So this would be a whisker example. Then we describe what it's about, what you need to get started, and then we show the student how to build them physically with the schematic and pictorial. And this is something we're quite good at around here, these kinds of drawings. Then we explain how the system works and then how to test it. So we always test things in subsystems, make the pieces work, and then we build upon it so everything is used together. So this is common throughout our tutorials. Going back to the top level, you will see underneath the main lessons are also projects. So these are all additional things we document that include additional hardware. A lot of fun stuff in there. Building it takes about 2 hours. This is often reported to be the first time using a screwdriver for many students. Have you heard that too, Kevin?
Yeah, absolutely.
And then what do we really want to communicate with this? What are we hoping students get out of it? First off, the use of code, how to write, rewrite, and iterate their code, and how to be precise with what they're doing, the interaction between their software and the hardware. So quite honestly, this is one of those things, robots, like we make them, they don't work until you make them work. So for most students who've had everything quite easy, this can sometimes be a challenge because you have software, electronic circuits, power supplies, some mechanical things, and it's all got to come together just right for everything to work. So the interaction is super important. We also teach students about the components they're using, how to identify them, what they do, what values they have, and we keep very careful track of this in our own inventory so things don't change because it could become very confusing quickly. In this example, an infrared LED looks like a photo transistor.
Yeah, and Ken, if I could add something right there, I want to just re-emphasize the fact that you're taking hardware and physical hardware, and we're using it in a context of cybersecurity. We're using and seeing the application that this hardware puts us, is used in the real world. And so, a lot of the examples that I like to use is when you talk about the LEDs, the sensors, you talk about a Roomba. When a Roomba bumps into something using the touch sensor, it's got to back up and it's got to go through a logic that backs it up, turns it a different direction, and continues on. And so being able to take the hardware and create and couple that with the application creates a level of understanding with these students. And then you put a layer on top of that of how do you secure the physical components with the application. And that's what I like to call the nirvana. That's where I like to call the aha moment in the classroom with students now being engaged to what this is. And so many folks like to challenge, okay, well, why is it that you're teaching physical computing or physical hardware, and how does it relate to cybersecurity? And these are the dots that we're connecting. And so I just wanted to take that opportunity to make sure that dot's getting connected with everybody.
Great. In this picture too, students will build this from a picture. We call that the circuit pictorial, and then the right side is the schematic. And this is a normal series of steps. They will just look at the picture and do that exclusively and take all those holes in the breadboard quite literally, but quickly they learn they can read from a schematic and totally move things around. So we progress in little steps. For teachers, you could send an email just like you can get NYSERC's curriculum for free. Our curriculum is public. And then all the teacher-only material you can get by sending an email to learn@parallax.com. And that's where you'll get our Google Slides, scope and sequence, standards alignments. We've aligned with Common Core, Common Core State Math, NGSS, the K-12 Computer Science Framework, CTE standards, 21st century competencies. And just now we're aligning with the North Dakota cybersecurity standards, Kevin, that you created.
That's correct. Yeah, so we do a lot of different state standards, but North Dakota is just the latest one that with their state level cybersecurity standards.
There is assessment material for each of the chapters that you can print as PDFs or change. There are also RTF formats, and the answers are put in the back of them. So these are quite handy. Okay, so let's see some projects, especially for the students that are sitting in class that are really anxious for all this. So I'll take you through a few of the tutorial projects first, and then we'll look at some projects and I'll tell you where we're going with the Cyberbot. So the first one is just a simple bump sensor. I'm going to switch my camera over. All right. So you should be able to choose between looking at the slide or the camera, and I think you can enlarge your own image. If not, let me know and I should be able to pin the video. So bump sensors are the most simple form of detecting a device. We call these whiskers, and basically when they hit the post here, the ground goes to the IO pin, which will read a 0, and when it's not hitting the post, they're grounded through the chassis of the robot. So when this runs, and it's currently set up just kind of to bounce off things. So of course you can program in all of your own durations and your speeds to do what you want to do. And this system works pretty well, but it's not perfect. But it's a lot of fun. So that's your first form of sensing that is done with the kit. And here's your schematic. Visible light. So I'm in quite a bright office in California, and the storm is cleared. But let's get this one out. So it's a phototransistors, light sensors, and they're pointed off the front there. Okay, and a few resistors and capacitors. So it's taking measurements at a very high rate and then comparing them and then making some decisions. So I have here a bright light outside, so it's going to be really hard to fight against the sunlight. I can to a point, but pretty soon it's going to say, no, it's not enough. I want to go outside. This is a fun project to do with a whole class of students. So if you set up every robot like this and you open your door, or wherever the light is coming from, and you turn off your lights, all the robots will move out of the room en masse. And you can add other sensors to avoid objects on the way, because here you're just following the light, but you can still hit things. So that was a lot of fun. And here's your pictorial for it and your schematic. Now here's another one. This is a more complex circuit. This is infrared emitters and detectors. And the way it works is the IR emitters send out IR light at a high frequency, and that frequency is what the receivers are tuned for. So let's grab a couple of these. And I've had teachers build this circuit pretty quick in class. Usually they could do this about 30 minutes in one of our workshops, but it's a tough one to build. So the LEDs have these plastic housings around them to prevent the light from scattering out the side. So it's pretty focused. And when it hits something, it'll reflect up to about 2 feet, and the receiver will see it. So this is a form of wireless object detection. And this works well unless there are, say, like black baseboards. So what do y'all think of that one? This is one of the more favorite circuits for sure. And there's another version of it. So if you can detect something, you can also follow something. So this would be doing the opposite. This would be turning towards the object. And this is using proportional control, PID, to keep a distance too. It's a very nervous robot, isn't it? And basically, you could use this to set up a line following robot and set it at slow speed, and then put a business card or a piece of paper behind that line following robot and have an autonomous vehicle competition in class and maintain your distance behind the leader. So a lot of fun. What do you think of that one? That's one of my favorite circuits. Let's talk about projects.
That's always was ours, and we see that in the classroom. That's one of our favorite activities because we can get a bunch of robots working together, and you set some of them to follow the light, you set some of them to follow each other, and that's where you get all the synchronization going on in the classroom.
Wait till you see some of the radio stuff. This is really crazy. Okay, before we get there, the ping sensor. This is an ultrasonic sensor, and this robot is outfitted with very fancy 440 screws that are hot glued onto the wheels. And I made this to create an ice driving over the snow robot. There's a video on our website for this. You can check it out. It works pretty well. Ultrasonic sensors, this one is the ping, and this works well up to 10 feet. So it's got a, I think I've programmed it for about 10 inches here. So it's driving and sweeping and then looking for the closest object over this 180-degree range. Might help if I put it up here. So this is the ice driver.
And do you mind if I allow someone to talk who has their hand raised?
Absolutely.
Okay, Kelly?
I think Kelly's muted. You might unmute Kelly.
I'm trying to unmute Kelly.
Sometimes I notice I've unmuted and they remute.
Mm-hmm. Kelly, do you have a question? I am trying to unmute you. You can also type your question in the question and answer pane.
Okay, so while that gets ready, here's another fun one. Okay, so this is just an infrared receiver, all right, connected directly to an I/O pin. And the Cyberbot library can read a standard Sony TV remote from Parallax. And in this project, it's going to receive and decode the different buttons on the remote. So 1 is forward left, and then 3 would be forward right. And you can guess what 7 would be now.
Back left.
Yeah, just, you know, a lot of fun.
Right. Yeah.
Kids go crazy with this. This is probably the cheapest form of remote control for a robot. And I think it works well up to about 20 feet. It can work across the room.
Ken, you ever seen the synchronized swimming on television? You know, you get 10 cyberbots doing this, and with one remote, all controlled to the same frequency, you've got synchronized cyberbots.
I think I have an example I'm going to have to show you.
Kelly, I believe you're unmuted, so go ahead and jump in if you have a microphone. Nope. Okay.
Okay, we mentioned cybersecurity earlier today, so I'll show you the beginnings of that. Basically RF, and the microbit has built into it a Bluetooth radio, which has a lot of nice features. You could just splatter it with data and it comes out the other side, and it has channels. You can use this for encryption, decryption, cipher keys, and all kinds of stuff. So at our office this week is 5 people from the NYSERC team, and we are keeping them here until they finish the curriculum. So they're
We're
working.
locking them in a room and
Yeah.
feeding them pizza.
They're probably, that's basically what we're doing. They're probably watching this right now, taking a break. So we'll have to go check on them. But these are their topics in cybersecurity. So we're using the Cyberbot to write code and to be able to demonstrate this in class. And they're using a lot of Python capabilities in it, like strings, dictionaries, error handling, and basic radio stuff, and like channels, this kind of thing, to do denial of service, authentication, encryption, key exchanges. And it's pretty cool what they've come up with. They've just been coding away, and now we're narrowing them down towards the examples that we will be using. This is one of them. So we'll take these 3 robots. You mentioned synchronized swimming. Okay, and I have a microbit, which I will use the accelerometer on it to send incline to the different robots, and you'll see they all receive it quite nicely.
And by the way, that handy orange case that is holding the battery pack that comes with the Microbit Go bundle is a 3D printing design made by, let me see, that was Matt Kinman at NYSERC. That is on Thingiverse.
Yep.
That's linked from our product
Yeah,
pages.
Matt Kinman.
Mm-hmm.
Yeah, Matt Kinman designed that. He has several designs within the that can host the microbit in its battery pack. So we've all got one, but yeah, I think it's all available on Thingiverse. Google or search NYSERC, NICERC, on Thingiverse.
So when I left the room, he had one microbit sending commands to a second microbit on one channel, and then to another channel, finally to get to the robot. So like a relay example with the radios. It was really neat. Line following is super popular, so we'll grab a line follower course. By the way, here's the super large robot chassis in development. And if you come to the nice, yeah?
I said I saw that in the background, Ken. I was wondering when you were going to unveil the huge Cyberbot.
If you come to the NYSERC Educational Discovery Forum this summer, you will see these huge Cyberbots running full size. It's going to be a lot of fun.
A lot of fun. We'll be in Minneapolis, Minnesota, June 22nd through the 24th. So sign up, go to our website, click on Cyber Education Discovery Forum. Parallax is a huge sponsor, a huge participant in that event, and Ken always brings something over the top, grandiose. And so this year we're going to have some giant Cyberbots running around.
The EDF is like my Halloween. I've been getting ready since June 20th last year.
Sure.
So here's a line follower, and it has on it 4 of these infrared emitter receiver pairs. So this is a project of reading all the different cases that might exist when this is on a black line or white. And I guess you can figure that out. Are there 16 different conditions which might occur, but how many do you really need to read? And then what do you do with all those conditions? So this is a super fun project. And I was suggesting earlier you combine this with the follower. So if you slow that down, you can have a self-driving project like this with this guy behind him. So, but of course the line follower is getting away from us, so it's kind of hard to demonstrate. Now, flipping this board over, something fun on the other side. And this is a project Andy is currently working on. So this is in development. And this is a line follower plus a ColorPal color sensor. Okay, and we're doing this because NYSERC has a competition where they like to use the ColorPal at their RARC, the Regional Autonomous Robot Competition. So this will turn right on red, turn around on green, and then turn left on blue. And we're still working out a few things with this code. Sunlight probably didn't help me there too much, but you'll see this coming from us in the next, I don't know, month or two. What do you think of that one?
This is great. This is a really a fun project. And like Ken, you mentioned, You know, we have our regional autonomous robotics competition, and it brings together all of the sensors. And what you're able to do here is to stack multiple sensors onto a robot to make good logical decisions.
And coming soon, here's a hardware device. This is the gripper, and many of our customers have seen this in years past. So what's really unique about this design is it uses one servo to close and lift. And the gripper paddles, once they've closed on the object, the remaining motion goes into lifting it. So you don't have to know the width of the object and worry about the extent of the servo range of motion. You just open or close is all you have to do, whether it's a big or small object. And this is a fully CNC machined gripper. We're building this here in Rockland and just actually getting 100 going through our machines today. So, yep, this winter or spring. Pretty neat. Any questions so far about all these things? I know it's totally overwhelming.
I have a follow-up to a question that was answered earlier. Joel asked if the only way to download code was by a cable connection, and we thought that was true, but Andy Lindsay was researching in the meantime, and it looks like there is an Android app under development that can load code using Bluetooth. It seems to be something in development that's a little buggy at the moment, but at least experiments are happening in that direction.
All right. Somebody also asked, can we come to Detroit? So we will come to Detroit.
Absolutely.
We'd love to. Yeah. Are you already there doing things, Kevin? Or
No, we don't. I don't think we've done a lot of workshops in the Detroit area. We've been all over around Michigan, but not specifically in the Detroit area. So one thing that Ken, if you don't mind, I'll take this
Please.
opportunity to mention that NYSERC has a team of professional development facilitators that travel around the country to educate K-12 educators. And so we host 1-2-day professional development workshops, and we do a lot of them in conjunction with Ken and his crew. We do a lot of joint presentations and a joint workshop. So Ken and Parallax's team have a whole slew of workshops. NYSERC and the NYSERC team have a whole slew of workshops. So happy, David, to connect with you, and we can work out to where, depending on what your level of interest are and the impact that we can make, we'd love to, one of us to come to Detroit.
Yep, we have workshops scheduled for teachers right now in Chicago, Southern California, Rockland, Utah, around the country. And we'll go wherever we have an audience of tech education, programming, CTE type teachers. So just put them in touch with us.
Is NYSERC planning to go to ISC in Vegas?
That's a great question. I don't believe we are planning to go on that. Do you have a date to that by chance?
I do not. John is asking. Maybe you could Google that really quick. While you're looking that up, I'm going to ask, Tim has asked, can I use the Parallax radar with a microbit?
With our library, yes. Mm-hmm.
If you're talking about the ping sensor.
Ping sensor. I was asking about the laser rangefinder.
It says radar.
Get some clarification there. Okay, Cyberbots. So Cyberbots come in a box like this. All right, they're just over $200. There are a couple ways to get them. Parallax Direct, Mauser has them. There's also a super kit that looks like this that has pretty much a lot of the parts you've just seen, plus rechargeable batteries and Cyberbots and a big banner like that one behind me for the classroom. So a lot of fun stuff if your budget can afford that. The Educator's Hotline. So this is something unique to Parallax, and we have a direct line for teachers to call us whenever they need to. And just to see if it works, I mean, someone should dial it maybe, right? And you'd be surprised. We answer this, we take care of your needs on the spot, and we don't keep you waiting. So we often talk to students, teachers that just have a simple problem or need a replacement part or whatever. So yeah, someone ring it. Let's see if it works. I'm on today. So call the Educator Hotline. workshops. We have an upcoming workshop in Rockland. See, there we go. So I got a call from Collinsville, Illinois. So yeah, you know it's working. I'll get you later. Call you back. February 13, we have a class in Rockland, and we are having 25 teachers here. We're giving you a robot. So come on over. There's no cost for it. You register on parallax.com/events. And then next week, if you like this webinar, there's another one on a different robot using Blockly, specifically Blockly Prop. And this is a very powerful system. It's a multi-core microcontroller and the most capable port of Blockly that exists for a microcontroller. So a lot to share in that one, so come on over. We'd like to take any questions too for the last 10 minutes or so, whatever's on people's minds, we can enable your audio.
We have the question about the parallax radar was referring to the X-band motion detector.
Ah, okay. I'd have to check on the interface. I don't know if it's it might just be a digital high and low.
Yeah, we didn't target it specifically with the libraries, but that would have to depend on its interface. That's something to explore further.
Yep.
There is a question about drivers for Ubuntu from Nikos.
Oh, from Nikos. Don't know about that. It's a good question, Nikos. Might have to send you a cyberbit and a microbit and you can find out for us. Anyone of the teachers out there watching the webinar already using the Cyberbot? I'd be curious too if you want to share any experiences you have so far. We're very interested in them. Okay, just let us know. And Kevin, can you think of anything we missed here? Stephanie?
No, I think we've covered a lot, and I think some of the takeaways that I just want to emphasize is that you've got so many resources that are available at your fingertips with Parallax and NYSERC and the partnership that we've created. And we would love to work with you, your school, your district to work with professional development, participation in Parallax and/or NYSERC events, and we want to make sure that everyone has the Cyber Education Discovery Forum on their radar, because if you are an educator within the United States and you attend this Cyber Education Discovery Forum, there is real incentive for you to attend. And I don't want to spill the beans, but I will let you know that every attendee that attends makes Ken and his team really, really busy. They are shipping out a whole lot of robots and a whole lot of supplies to attendees who teach, attendees who attend the Cyber Education Discovery Forum. So you're going to want to be there. And Jackie, I see in the comment section, yes, there is. So she gets the hint. She knows.
One teacher mentioned using the Arduino. So I didn't discuss this, but if you have other Parallax robots, you can convert them to a Cyberbot. Some are really easier than others. The Arduino Shield bot is a pretty easy one to bring over.
I'm putting a link in the chat pane to our conversion kit.
Oh, great. Okay.
That will take a basic stamp bot or a shield bot for Arduino and convert it into a Cyberbot. So
Kevin, since we're near the end here, maybe we should send a few of these out to some of our participants.
I think so.
And
so how do we want to draw? You may just, you want me to just scroll? I'm going to scroll, and then I'm going to close my eyes. I'm going to scroll, and wherever my mouse stops, which is going to be Teresa Hendrickson.
Oh, wow. Yep. So Teresa, you have I believe, an American shipping address. That's a good thing.
That's fantastic. So Teresa, if there's a way that you can ping one of us in the chat with your contact information, and we'll be sending you a device. So let's see. Scroll through. We're going to find eyes are closed. Let's go Jim. Is it Kinney? Jim Kinney.
Oh, okay. I have to send him one anyway because he's going to be answering questions on our forums. So
Oh, nice.
Maybe you
All
need to
right. All
pick one
right.
more.
keep
All
going.
right. We'll pick one.
Jim,
We'll pick
follow
one
up my
more.
email. I gotcha.
Okay. We've got Stephanie Frazier.
All right, a robot
Stephanie
winner.
Frazier. Another robot winner. So,
Okay.
Teresa and Stephanie, I look forward to getting you some devices in the mail.
Yeah, that's great. You'll be programming, let's see, by next week.
By
There
next
are
week.
many questions coming in about whether you're going to be in a certain area or how to find out information about the
Okay.
Chicago course. I'm going to put here in the bottom of the chat pane is a link to our company Follow Us page. If you scroll down here, there's a link to join our newsletter. And the best way to do that is to enter your email address and click education and then click submit. And that will get you on our education list for sending out announcements about when we have educators courses and webinars coming up.
And if you want to see what's scheduled, parallax.com/event shows all of our
Yes.
webinars and workshops. Right now we have five more workshops we're adding. Some of them are often closed, like Chicago Public Schools will be for their teachers only. But when possible, we try to make them public. So if you can bring us, if you're a teacher, bring us your whole district. That's always the easiest thing to do. And we will come for a day, bring robots, and teach everybody. So if we don't have something, we want to go there.
Right. I'm dropping the link in ours as well. And so if you don't see your workshop or your region in the list, there's a form to fill out, and we'll gauge some interest and send a crew your way. So NYSERC.org/PD, professional development. So NYSERC.org/PD.
Great. Want to thank everybody for attending. Thank you, Stephanie. Thank you, Kevin, and to the many people that watch this live. We'll see you around.
Yeah, absolutely. Thank you, Ken. It was a pleasure.
Likewise. Bye now.